Hi everybody, I wanted to make a quick video just to talk about the appetizers on Tuesday, like you probably read in my email. What I want to talk about is just how these patterns work and the amazing way that kids are seeing them. So I always start by putting a pattern up on the board that looks something like this. In fact, actually I would put usually three stages of the pattern up, and students have to figure out what the pattern is, how it's changing, how it's growing. And then what we do is they draw the fourth in the series. So here's the first stage, here's the second stage, there's the third stage, and then I would ask a student to come up and draw the fourth stage, what it looks like. And pretty much by that time, kids can generalize what any stage in this pattern would look like. You could ask them, what does the 10th look like, and they could describe that in words. Once kids get to that point, then they are often able to start generalizing that into an expression. And so I just wanted to talk about that, because by this point in the year, this is an example of what kids are coming up with. And this is actually a pattern that we did a few weeks ago. So I always give kids credit for the way that they see the pattern, and so that's why you see the names on here. Sylvie sees the pattern as n squared plus n. And what she does then, when she talks about this, is she shows us how she sees it. So she sees it as this side is n, or the stage number, and this side is n, or the stage number. And so the pattern is n squared, because to find the number of squares you would have to do n times n to get n squared, plus n, which is this 3 right here. So that is how Sylvie sees it. And so she explains why she thinks that this expression n squared plus n is the way that she would write the generalization. So Griffin, just to see a different example, he thought of this pattern as taking another copy of this and flipping it over. So I'm going to do his in green. Hopefully you can see that. In other words, he thought of it like this. So if it was an entire rectangle, and then he would just chop that rectangle in half. So if he was to do it this way, he said this side was n plus 1, because it's one more than the stage number, which is 3. And then this side, he noticed, was 2 times the stage number, or 2n. So he said to find the total number of squares, you would multiply 2n times n plus 1, and then divide that whole thing by 2. And that's what he did here for his expression. Ezra did n plus 1 times n, and what he did is he just took, what did he do? Oh yeah, so he called this side, so the red right here, he took this little chunk and he moved it up here, so it kind of turned and it filled in this spot. So then he created a rectangle that had the dimensions n plus 1 right here times n right here. And so he said you could find the whole thing just by moving that and doing n plus 1 times n. And then Clyde, and by the way, they're all correct. You're going to see that in a second. And then Clyde said, what did he do? I'm trying to remember. So he did 2n times n. So he said this whole dimension right here is 2n. So it's 2 times, in this case, 3, the stage number. He noticed that that was always double the stage number. Times this right here is n. So he was making this rectangle, and then he realized he has to subtract all of this kind of negative space there, if you call it that. And so he had to subtract this little rectangle, which has the dimensions n by n minus 1. And so that's why he came up with this expression. What we do after that as a class is we go through and we simplify all of our expressions so we can see that they are actually all the same, even though they look how different they look. And so Sylvie's is as simple as we can get it. But then what we'll do is we'll practice simplifying. And so here we're going to distribute the 2n times the n, and we get 2n squared plus 2n, and we divide that by 2. And so we end up here, when we simplify that, with n squared plus n, which matches up with Sylvie's. Ezra's, we're going to distribute this n times n and get n squared. N times 1 is n, and we end up with n squared plus n, which matches Griffin's, which matches Sylvie's. And then Clyde's, we end up with 2n squared minus, and then we distribute this, and we get an n squared minus an n, or actually plus an n because we subtracted a negative, so we end up with 2n squared minus n squared is just an n squared plus n. So Clyde's matches up with Ezra's, which matches with Griff's, which matches with Sylvie's. So this is what we work on every Tuesday at the start of class, and kids, as you can see from this, are simply blowing it out of the water. They're just amazing algebraic thinkers. So I hope that that helps you kind of get a sense for a little piece of what we're doing in math is going. Thanks for watching.